Welcome back to HackerNews.fm, your unofficial, fast-paced tour through the top stories from Hacker News for December 6th, 2025.
Today we've got some wild ones. How Oxide is actually using LLMs in production, why Claude is weirdly brilliant at one-shot decompilation, and a few hot takes on what really killed Perl.
But first, we're starting with privacy and patching, why one Android fork claims it's miles ahead on security.
Let's dive into our first story. GrapheneOS is the only Android OS providing full security patches.
Next up is GrapheneOS is the only Android OS providing full security patches, which climbed to number 2 with 559 points and 248 comments.
Yeah, and the post itself is basically a Mastodon thread from the GrapheneOS team bragging, maybe justifiably, about their security preview releases.
They say their preview channel has had December 2025 Android security patches since September and is already carrying fixes out to March 2026.
For folks not steeped in this, Google ships security patches monthly, but OEMs get preview patches months early, under embargo, to test and integrate.
GrapheneOS is taking those and shipping an opt-in preview build, so you can get pre-embargo security fixes on your phone before everyone else.
And they claim, quote, GrapheneOS is the only Android-based OS providing the full security preview patches, with Samsung and stock Pixels only getting pieces of that set.
HN really latched onto the trade-offs. One commenter loved that you can opt in to pre-embargo security releases, bypassing the vulnerable window between disclosure and OEM updates.
But another shot back that this means the only fully patched Android builds are binary-only distros, either Google's Pixels or the GrapheneOS preview channel.
And the spiciest take was the person saying these early binaries let attackers diff GrapheneOS images to find 0 days still unfixed on everyone else's Android.
Right, the classic tension. Is it better to patch a subset of users early, or keep everything closed until everyone can patch at once?
There's also meta drama. One commenter complained about the GrapheneOS obsession with picking a fight with everyone else, and someone else replied with that unreasonable man quote defending them.
Love it or hate it, this thread shows how messy real security is. Timelines, embargoes, binaries, personalities, and GrapheneOS is forcing that conversation into the open.
Next up is using LLMs at Oxide, which, hit number 1 on Hacker News with 283 points and 118 comments.
Yeah, this one's Brian Cantrill's RFD 576. And instead of a simple do-don't checklist, it's all framed around Oxide's values: responsibility, rigor, empathy, teamwork, and then urgency, very deliberately, last. For those who don't know, Oxide Computer builds on-premises cloud infrastructure, basically rack-scale systems designed from the ground up, both hardware and software.
The responsibility bit really sets the tone. He basically says, look, LLMs are just tools, and Oxide employees bear responsibility for the artifacts we create, whatever automation we might employ. Human judgment has to stay in the loop.
And he is pretty brutal about using LLMs as writers. He calls the prose hackneyed and cliché-ridden at best, and at worst, like walking around with your intellectual fly open, which Hacker News absolutely loved quoting.
He goes further, saying LLM-written text kind of breaks a social contract. Readers assume the writer did more work than the reader. If that's not true, trust erodes. But as editors and readers, LLMs get a thumbs up, especially for summarizing big specs and tightening already polished drafts.
Same thing with code. LLMs are fine as code reviewers, debuggers, even animatronic rubber ducks. And they're surprisingly good at writing throwaway or experimental code, as long as the engineer actually owns and reviews what ships.
Hacker News really grabbed onto the senior-junior divide. One commenter warned that juniors might know less programming over time if they lean too hard on LLMs and quietly wreck codebases with plausible-looking mistakes.
And then you've got the generational clapback. Another commenter compared this to the old complaints about Google, syntax highlighting, autocomplete, and just ended with, Today is today. Use all the tools at hand. Don't shame kids for using the best tools.
You know, we should probably acknowledge the elephant in the room here. It's a bit meta that we're talking about LLMs and writing quality on an AI-generated podcast. Our human editor actually chimed in to say he's been pleasantly surprised by the quality of LLM writing for this podcast, but it does have a telltale signature after a while, and having a human in the loop definitely helps.
He also mentioned he thinks you can generate first and have a human edit later, which is a workflow Oxide's post seems to downplay. But that debate aside,
Yeah, the vibe is, tools keep evolving, but Oxide's line is that your character and your craft still matter more than whatever autocomplete you're using. And that feels like the right place to land, at least for now. Next up is the unexpected effectiveness of one-shot decompilation with Claude, which rocketed up to number 7 on Hacker News with 199 points and 106 comments. It's all about using Claude to chew through decompiling Snowboard Kids 2, this old N64 racer.
yeah, and for folks who aren't deep into this world, decompilation here means taking raw machine code and recovering C that, when you recompile it, produces bit for bit the same binary. That matching decompilation requirement is way stricter than just, it runs and doesn't crash.
The twist in this post is moving from human-in-the-loop tinkering to what he calls one-shot decompilation. Claude runs in headless mode, gets a prompt for one function, and, as he puts it, Claude follows the prompt and exits. He says 3 weeks of this made more progress than the previous 3 months.
And the whole pipeline is very Unixy. There's a scorer script that ranks functions by estimated difficulty, and Claude always tackles the easiest remaining ones first. There's even defensive tooling, like a build script that literally prints, "build has failed." Claude, you should treat this as a build failure, just so the agent doesn't get confused.
Which is, honestly, extremely good robot wrangling. Hacker News seemed to really appreciate that engineering. Simon Willison jumps in early to explain that matching means your reconstructed C compiles to the exact same machine code, and he links back to the earlier blog post for context.
And then there's this little bike shed over whether one-shot is the right term if Claude is looping internally with tools. Like, is it really one shot if there's a whole mini-agent system behind the scenes?
Yeah, the semantics police showed up right on schedule. My favorite comment, though, was from Sagar Jha, warning that this only works because the author has tight heuristics and a really narrow goal. They write, "What LLMs are, still, not good at is one-shot reverse engineering for understanding by a non-expert."
Right, so this isn't click a button and suddenly you understand a giant code base. It's more, click a button and the machine grinds out matching C for a specific, well-scoped function.
There's also that thread worrying this could make everything de facto open source, and people quickly push back. No, at best, it's source available. Licenses still bite, copyright still applies, lawyers still exist.
The bit that stuck with me is his estimate that something like 79% of the game's functions look matchable with Claude now, which means the bottleneck is drifting away from human reverse engineering experts and toward compute and model access.
And if that holds, I think we're going to see more of this style of work. Let agents grind through the bite-perfect stuff, then humans come in later to clean up, document, and actually understand the code.
Pretty wild moment for game preservation and reverse engineering. It's like the grunt work just got automated, and now we have to decide what to do with all the time that frees up.
All right, next up is Perl's decline was cultural, not technical. This one actually hit number 1 on Hacker News, 231 points, 287 comments. So, yeah, people had feelings about this one.
Yeah, and it's written by someone who was doing serious Perl back in the 90s and early 2000s. Their argument is basically that Perl didn't lose because of missing features. It lost because of the culture around it. We'll throw the link in the show notes.
Yeah, he paints this really classic BOFH world. Old school Unix admins, RTFM, losers, wizards, all that gatekeepery stuff. And says the norm basically became, it's okay to be rude if it's for a good cause. Which, shockingly, doesn't age super well.
And then there's Tim Tau TDI. There is more than one way to do it. Plus CPAN, the big Perl package repository. Amazing for power users. But it sort of entrenched this fort inside a fort, where only the wizards are allowed to touch the core language. We'll link that piece too.
And Hacker News really pushes back on all that. A lot of people are like, no, Perl just had this confusing syntax full of at and %, and they call it write once, read never. So teams eventually just bailed on it.
One commenter had a nice bridge between those two takes. They said the real flaw was letting everyone evolve in different directions while cooperating, which sounds great in theory, but it doesn't really scale when you need engineers to be interchangeable on a big team.
Perl 6, now Raku, becomes this huge flashpoint too. The article itself calls it a schism, not a murder weapon, but HN has people just flat out saying Perl 6/Raku killed Perl, and basically froze Perl 5 in place.
Meanwhile, Ruby and Python stroll in with these much friendlier communities and really clear stories. Rails for web apps, Python with batteries included, and way less monk and wizard cosplay on the mailing lists. That contrast really matters.
There's even a thread about Sapir-Whorf, how your first language shapes how you think, which kind of matches the author's point that languages are social clubs as much as they are tools.
And yet, people in the thread are still happily using Perl for small scripts, build systems, weird Unix boxes. It's legacy, but it's not dead. Not by a long shot.
Yeah, I like that the piece ends there. Perl really did change the world. It just couldn't change itself fast enough. The lesson feels way bigger than Perl. Communities can totally gatekeep themselves into irrelevance. Next up is touching the elephant, TPUs, which hit position 3 today, around 167 points and 49 comments. It's this big deep dive into Google's tensor processing units and how they actually work.
Yeah, and it opens with this great line about the mythological reverence for Google's tensor processing unit, with Google sitting imperial and singular while everyone stares at NVIDIA instead. Then it very deliberately demystifies that, like treating TPUs as mythology risks making the TPU seem like magic.
For folks listening, a TPU is basically a custom chip just for neural network math, mostly giant matrix multiplications. And the article really leans into that. Neural nets are simple compositions of matrix ops, so you build silicon that only does that really, really fast.
TPU v1 is framed as this Spartan device aimed at making inference fast. A 256 by 256 systolic array of 8-bit max, no cache hierarchy, no branch prediction, nothing fancy. A systolic array is like an assembly line of tiny calculators, each one passing partial sums to the next one every clock tick.
Then TPU v2 shows up as the training chip. Dual cores, HBM, interchip links, and BrainFloat 16, so you keep wide dynamic range but with cheaper math units. It's a neat example of just changing the number format so you can pack more compute into the same power budget.
My favorite part was the optical circuit switching in TPU v4 pods. 4,096 chips talking over these little MEMS mirrors. And the author points out OCS optical components are under 5% of system and power costs, yet buy you huge flexibility. That's the warehouse-scale computer side that most blog posts just skip.
Yeah, and the software stack finally gets its due. XLA, Borg, libtpunet, all coordinating slices and collectives. The article just flatly says, the software is as much a part of the TPU story as the hardware. One HN commenter loved that, saying, the work that XLA and schedulers are doing here is wildly impressive.
The thread really split there. Some folks called it a nice breakdown that connects the concepts in a way that clicks. And then one person just drops, I've never seen such obvious slop. The author actually replied, the effort here was earnest, and I'm sorry it reads as slop to you. Which I respect, honestly.
Same. Then there's this whole geopolitical tangent. One commenter notes China allegedly stealing TPU v4 v6 docks and a startup already selling TPU-like clusters, wondering if that's a deadly blow for NVIDIA and Google. And immediately someone answers, manufacturing is the hard part. There is a dark art to semiconductor manufacturing that pretty much only TSMC really has the wizards for.
Others push back that China already runs 7-nanometer fabs and designs serious AI chips like Ascend. So the gap is shrinking. But the consensus was, you can copy an architecture a lot faster than you can copy a bleeding-edge fab.
Power came up too, which makes sense when the article quotes a TPU pod at 10 megawatts. HN folks were debating whether we'll actually build nuclear just to run these data centers, versus the more immediate reality of solar, batteries, and gas.
I like that the article keeps circling back to target TCO over CapEx. It's not just the chip. It's the racks, the network, the schedulers, the electricity bill. If you want to understand why TPUs aren't magic, but still kind of miraculous engineering, this post, plus the HN comments, is a pretty great rabbit hole.
Next up is Instant Supercompute, launching Wolfram Compute Services, which actually hit number 1 on Hacker News. 221 points, 118 comments, the whole circus.
Yeah, this is Stephen Wolfram basically rolling out a one-liner to get a supercomputer. You run remote batch submission environment, Wolfram batch, and suddenly your little notebook can fling jobs to Wolfram's cloud.
And then you just wrap your heavy computation in remote batch submit, send it off to their cluster, and you literally get an email when it's done. He demos it on goofy but fun things like tiling random pentagons or searching 100 million cellular automaton rules.
Under the hood, he's talking machine sizes from basic 1x8 up to like 192 cores and around 1.5 terabytes of RAM. You pay with credits, and you can set time and credit limits so you don't accidentally, melt your credit card.
The top HN comment was really nostalgic. Man, I miss Wolfram language. Once you've twisted your brain a little, it's an incredibly high-value tool. And then someone riffs, when Python is batteries included, Mathematica is spaceship included.
But the thread immediately pivots to, if this were open source, it could have changed the industry. As expensive proprietary software, it'll stay niche. That tension just dominates the comments.
Some folks push back like, hey, it's $195 a year personally, $75 for students. That's not insane. Others argue even that creates a class of haves and have-nots and fragments an already tiny community across versions.
One commenter goes further and says, Mathematica is pretty irrelevant in computing, and that as a proprietary system, it'll never be important. And then a bunch of physicists show up like, we literally use it every day on department or university licenses.
And of course, the open source versus commercial flame war shows up, with one commenter arguing that source code should just hit the public domain after a decade. Classic HN values clash.
People also air all the long-standing gripes. 30-second startup times, weird scoping rules, cryptic error handling, notebooks that diff terribly in Git. But then they admit the function library keeps pulling them back in anyway.
My favorite aside was someone saying now they'd just ask Claude to work things out. But that Mathematica plus an LLM is almost ridiculously powerful as a combo. That's a neat mental model. Wolfram language as this giant math and visualization engine that an LLM can drive.
And Wolfram's clearly leaning into that tool for himself vibe. One commenter says he builds for his own use and lets others pay to tag along. Somebody else answers that's actually the strength. Kind of like early Apple building tools for jobs.
The HPC kit bit at the end is interesting too. Plugging remote batch submit into your own on-prem cluster so you get the same one-line to supercompute thing, but on your own hardware instead of Wolfram's cloud.
So if you already live in Wolfram notebooks, this is instant, nicely polished HPC. If you're in the Python/Jupyter ecosystem, it kind of reads as a very slick, very walled garden.
Either way, it's a nice reminder that serious compute tools don't have to look like Kubernetes YAML. Sometimes they look like one function call and an email when your universe search is done.